Alright, today's lesson is S.2, domain of radical functions. Very similar to domain of rational functions, except radicals are different than fractions. Our goal today is to be able to identify all the possible inputs for a radical function. So there's obviously going to be some limitations for radical functions. First, let's define what a radical function is. It's a function that includes the input variable, which is x, in the radicand. And a radicand is what you see down here. Sometimes it's a square root, sometimes it's a cube root, but it's this little house-shaped image. But an equation or function with a radicand would be f of x equals -3 times. Under the radicand, you might have something like x plus 2, and then outside, you might have plus 5. So this is what an equation looks like with a variable under the radicand. And then a graph of a square root function, looks something like this. You'll never see a square root function come down on this negative side where the x values are negative, because you can't have the square root of a negative number, and that's the limitation here. So when we try to figure out what the domain is of these radical functions, we're trying to figure out what's the smallest possible number that we can take the square root of, which is 0. So that's how we're going to set those up. But go ahead and write that down in your notes, where the limitation is no negative numbers inside a radical. If you have a negative number inside a radical, it's called an imaginary number, and in Algebra 1 we're only dealing with real numbers. You'll see imaginary numbers as you start to transition into Algebra 2. But just quickly, why can't you have a negative number under the square root? Well, if you think about it, when you're taking the square root of a number, you're trying to figure out the factors of that number, or pairs of a number that you multiply by itself to get that number. So the square root of 9 is 3. So you think, okay, well, if the square root of positive 9 is a 3, then the square root of a negative 9 is also, or is going to be -3. That's what our intuition tells us. But that's not true, because if you think about it, -3 times -3 is a positive 9. So the square root of 9 is 3, and it's also -3. -3 times -3 does not give you a -9, so that is not the square root of -9. So that's it's kind of a little complex idea, but for now all you need to know is that you cannot have negative numbers inside the radical. So we're going to figure out what numbers can we put in for x that will not give us a negative value under the radical. So if you're looking here, you see this equation. Just to give you an example, let's say we take this equation and we write it in terms of x. So we say f of x equals x plus 1. Okay, let's go ahead and find what f of 0 is. So put in 0 for x. We got 0 plus 1, which is the square root of 1, which is 1. So we put in 0, we got some value out for y. 0 is part of our domain. What if we put in f of -1? Well, if we put in -1, we got -1 plus 1. -1 plus 1 is 0. And we can take the square root of 0. That is actually the smallest number you can take the square root of. So I'm going to go ahead and make a note right there. So this is the smallest value that we can square root. So what would happen if we put in, let's say, -2? So what would f of -2 be? That would be -2 plus 1, which would be the square root of a -1. So this is our limitation right here. We've got a number that's a negative under the radicand. So this number -2 cannot be part of our domain because it results with this negative under the radical. So this cannot be part of our domain. It's a limitation. So how do we figure out all those numbers, not just one number, that cannot be a part of our domain? Very, very similar to what we did with rational functions, except now what we're going to do is we're going to take what's inside the radicand, so in this case x plus 1, and we're going to set it greater than or equal to 0, because 0 is the smallest number that we're allowed to have under this radicand. That's why we're setting it greater than or equal to 0. So I'm going to take x plus 1, and I'm going to set it greater than or equal to 0, and now I'm just going to solve this like I would an equation. You know the rules for solving are the same for inequalities, except when you divide by negative or multiply by negative, you've got to flip the sign. We've got 0 here, so x is greater than or equal to 0 minus 1 is a negative 1. And if I put this into Schoology, I'm going to type it as it is. So x is greater than or is equal to negative 1. So this would be my Schoology answer right here. This would be my domain. X is greater than. All values bigger than or equal to negative 1. Okay, example number 2. So we're going to take what's under the radicand. In this case, we've got a negative 3 minus x. This plus 2 out here doesn't really, there's no limitations on this. The limitations are strictly what's under the radicand. We can have a negative. So we're going to take this and set it greater than or equal to 0, and now we're going to solve. So plus 3 to both sides. We've got negative x is greater than 3. Now we've got to get rid of this negative. It's honestly negative 1, so we're going to divide by negative 1, divide by negative 1. That becomes positive. We've got x, but we divided both sides by a negative. So this is a special rule for inequalities. When you multiply or divide by a negative, comma, you've got to switch the sign. So I'm going to switch the sign the other direction. Now I've got a less than or equal to, and that's negative 3. When I put this into Schoology, I've got x is less than or equal to negative 3. Example number 3. So again, let's take what's under the radicand. Is greater than 0. Remember, we don't need to worry about this 5, and this negative is not important for us as we find the domain. We're going to go ahead and add 3, add 3. We've got negative 2x is greater than or equal to 3. We're going to divide by negative 2, divide by negative 2, flip the sign. We've got x is less than or equal to 3 divided by negative 2. If I put this into Schoology, I put it in just like, and put that negative out in front, just like that. So I'm going to move this negative to the front just because that's how you would put it into the computer. And here, our domain. So what's under the radicand? The number 5. There's no variable under the radicand, so our domain here is all reals. So there's only a limitation when the variable is under the radicand, because there's no possibility of having a negative under the radicand if it's just a number 5. Last one for today. So we've got our radicand right here. We've got it being divided by 5 and plus 1, but these aren't under the radicand, so we don't need these for finding our domain. We've got x minus 2 is greater than or equal to 0. Add 2, add 2. X is greater than or equal to 0. No, to 2. So 2 is the smallest number. 2 is the number that when I plug it in for x will give me 0, and that's the smallest value that I can take the square root of. So I've got x is greater than or equal to 2. Good luck on the homework. Please message me or your classmates in Schoology if you are struggling.